Hey guys, today we are going to solve the problem counting triangles in the two-pointer approach section of InterviewBit. I am Algo Conqeuror. Let's get started with the video. The problem states that we are given an array and considering each element as an edge, we have to find out the number of triangles which we can form using these edges. So that's basically the question. How can you solve this problem? If you remember what you have learned in your 10th class, I think it could be easy for you because this is the basic 10th math that we are going to use in this problem. I hope you had a chapter called Properties of Triangles in your 10th. In that, the basic property of a triangle with respect to its edges is this. If we have a triangle of edges A, B and C, the first condition, these three conditions should hold for that triangle in order for that to be a triangle. The sum of two edges should be greater than the current edge. The sum of other two edges should be greater than current edge. That's basically these three conditions. Now let's take a triangle in which A is less than B and B is less than C, a general triangle. C is greater than A and B. So can I say that these two conditions will always hold? Please observe carefully. C is anyhow greater than A and we are adding more power to it, so this condition will definitely become true. Same for this case. C is definitely greater than B and we are adding some more to C, which implies that this condition is going to be true. But let's look at this condition. In order for A and B, which are both less than C, to be greater than or equal to C, we have to look at this condition. These two conditions are true by default, but this condition is not, because A plus B could be less than C or greater than C. We just have to check. We can't be sure. That's the first part of this problem. Now, if we are given with an array, so first we'll try the brute force as usual. The brute force will be 3 loops I, j, k, and checking whether these three elements will form a valid triangle. If these three elements form a valid triangle by these conditions, then we'll update the result and return the result. This is the brute force way. We have 3 loops here, one inside another, so the complexity will be n cube, big O of n cube. So how are we going to optimize this? As we discussed earlier, that we just have to take care of this condition. These two conditions are true by default. We just ignore them. The only condition we need to look at is this condition, where in the triangle A is less than B is less than C, for this triangle to be, for this, if A, B, C can form a triangle, this condition must hold. So that's what we are going to solve. As we know, C is greater than A and B. So if we run a pointer from the rightmost of the array and check for the elements towards its left, if any two elements are whose sum is greater than the current element, that could form a valid pair, right? That will definitely form a valid pair. Don't worry, I'll repeat it. The array is given as 1, 1, 1, 2, 2. Let's take a pointer from this. I'm considering this pointer, the pointer, to be the greatest edge of the triangle. As the array is sorted, I'm considering the rightmost part as the greatest edge of the triangle. And if I am able to find two elements towards left of this pointer whose sum is greater than the current element, then that could be a valid triangle, right? Let's say the C is 2. C is equal to 2. The pointer is pointing to 2. We need to find A and B such that A plus B is greater than C for ABC to form a valid triangle. So we just have to find the pairs whose sum is greater than C, whose sum is greater than the current pointer. So if we take this 2, how many valid triangles can we form? I can take this one and this 2, which will give me 1, 2, 2. These are ABC values. 1 to 2 could be a valid triangle. And if I take this one and this 2, then also 1 to 2. So I said this one, this 2 and this 2. And if I take this one also, it makes a valid triangle, right? 1 plus 2 is 3, which is greater than 2. So one more, 1, 2, 2. So we have found 3 pairs. Now we are done with this pointer and we'll move this pointer towards left. Now the pointer is pointing here. So how many triangles can this 2 form? With C is equal to this 2, how many triangles can we form? We practically can't form any triangles, right? Because no two elements in this part of the array has sum greater than 2. The sum is equal to 2, but it's not greater than 2. So we can't form any triangles with C is equal to this 2. Now let's move the pointer ahead. It became clumsy. I am drawing it again. Now the pointer will be here. C is equal to 1. Now we have to find A and B such that the sum is greater than 1. Can we find that? Yes, right? If we take these two ones, we can form a valid triangle. The sum of these two ones is greater than this one. So 1, 1, 1. So how many triangles were we able to form? We formed 4 triangles. So the number we have to return for this array, the number of triangles that we can form, the number of valid triangles that we can form are 4, as we have seen here. So this is the approach, guys. I am just making a summary of it. We just have to come from the rightmost part of the array. We have to take a pointer towards the rightmost point of the array and check if there exists the number of pairs whose sum is greater than current value. We just have to find the number of pairs whose sum is greater than the current value. The problem reduces to this. Now, how will we solve this? Previously, in the first video, we have discussed the problem pairs with a given sum, right? Do you think these problems are a little bit similar, on same lines? These are on same lines. Yes, right? We just have to find a pair whose sum is greater than current value. Previously, we discussed sum of the pairs with given sum. So what are we going to do that? What concept do we use for solving this problem? Yes, that's two pointer. So for each C pointer, I'm calling this pointer as C so that you will not get confused. For each C pointer, I'll run the two pointer technique towards the left subarray of this array, and what I'll try to find the number of pairs whose sum is greater than or greater than this one. And how exactly can I find that? So the problem reduces to, you are given an array and a value b, which is this. You have to find number of pairs whose sum greater than b. That's right. Now for these two pointers, where are you going to place the pointers? Here, because if you place them here, the decision is not, the decisions are ambig. So we are going to place them one towards left, one towards right, and calculate the sum. Is the current sum, what is the current sum? The current sum is 3. Is 3 greater than b? Is 3 greater than b? The b's value is 2. Yes, right? 3 is greater than 2. Now think and tell me how many pairs will form such that this 2 is included. How many pairs will form such that this 2 is included in those pairs? If 1 is a valid pair, then this one will also be a valid pair, because anything towards right of this one will increase the sum rather than decreasing it. So if this one is forming a valid pair, obviously the one towards its right also will form a valid pair, right? So how many pairs these two can form? This can form 3 valid pairs, right? So what I'm telling is, if you are at the left, let L be a left pointer and R be the right pointer. If this gives you the valid sum, the number of pairs which include R is equal to number of pairs is equal to R minus L. Let's write the indices 0, 1, 2, and 3. For this case, L is equal to 0, R is equal to 3. And how many pairs are valid such that 2 is included in that? 2 is included, R minus L, 3 minus 0. As we have seen, we could form 3 pairs, right? So we can form R minus L pairs in which R is included. And we have taken care of this 2, as we have considered this 2 as R and found out the number of pairs. Now what will we do? And we'll consider this 1 as R and find out the number of pairs. And we'll consider this one as R and find out the number of pairs. We'll go on do that. We'll go on doing that. That's how we solve this problem. I know it's a bit confusing, but if you see the code, I think things will get more clearer. Yeah, here's the code. Yes, here is a code. Firstly, you just have to sort the array because you are going to apply two-pointer approach. And now I told you that you are going to consider C, which is a greatest side in the triangle, from the right. You are going to start C from the right and run the two-pointer approach in the left side of the array. That's what I have assigned here. L is assigned to 0 and R is assigned to I minus 1, the current pointer minus 1, which is this denotes that we are running the two-pointer approach in the left part of the I. So now what did we discuss in the explanation? If the current sum is greater than the required is greater than C, then R and L are forming a valid pair, right? So how many pairs such that R is included in those pairs? How many pairs can be formed? R minus L. I have told you that, and we will add that count to the result. And if the current sum is less than the required C, what will we do? We will just increment the L because the sum gets increased. That's why we are incrementing the left pointer. And this is the important point. You have found out the number of pairs in which R is included. Now you should move the right pointer towards left so that other values are also considered. This is the code. If you dry run this, you will get more clarity. And this is all for this video, guys. And thanks for watching this video. Please do subscribe and share my channel. Thank you.